Okay, today we're going to be continuing our notes with 16.3 on simple probability. So probability is a measure of the chance of a specific event occurring, and it's notated as the P of E, or the probability of E. So the probability of an event occurring. Okay, it's expressed as a ratio of favorable outcomes to the total number of outcomes. Okay, so what this means is it's a fraction or a ratio where our favorable outcomes or the outcomes we want go on top and the total number of outcomes goes on the bottom. Okay, so the ratio can be written as a fraction, a decimal, or a percentage. The sum of all the probabilities in the sample space is equal to 1. Okay. Looking at some examples here, it says give each probability as a fraction, in the simplest form, a decimal, and a percent. What the probability of this spinner landing on 9? Well, looking at this spinner, how many of these slices have the number 9 on it? Well, one of them has the number 9 on it. That's my favorable outcome, or my outcome I desire. Got 1 out of 16 different outcomes. Let me fix my pen here real quick. There we go. So I've got 1 out of 16 outcomes. That would be my fraction. Now my decimal would be 0.0625, and I just get that from plugging my fraction in the calculator. And my percent would be 6.25%. Okay, now what is the probability of spinning at least a 12? So 12 counts as at least 12, and any number bigger than 12 also counts. So we've got 1, 2, 3, 4, 5 numbers that are at least 12. So 5 out of our 16 would be my probability. Or the decimal version would be 0.3125. And as a percentage, that would be 31.225%. The third one, what's the probability of rolling or spinning a perfect square? Well, perfect square, we've got 1, 4, 9, and 16 are all perfect squares. So we've got 4 out of our 16, which does simplify. Simplifies down to 1/4. So that would be my fraction. And my decimal would be 0.25. And my percent would be 25%. Now, what is the probability of spinning a not shaded color? Well, we've got all of these white ones are not shaded. So 1, 2, 3, 4, 5, 6, 7. Got 7 out of our 16 numbers. Or written as a decimal, it's 0.4375. Or as a percentage, we've got 43.75%. Okay, now what's the probability of rolling a 2 or an 11? Well, I've got the 2 here and the 11 here, so I've got 1, 2 of my 16. So 2 over 16, which simplifies to 1/8. That'd be my fraction. My decimal would be 0.125, and my percent would be 12.5%. Okay, the last one on this example is any multiple of 5, probability of a multiple of 5. So multiples of 5, we got 5, 10, 15, and that's all that are on this spinner. So we've got 3 of them, 5, 10, and 15. So 3 out of the 16. Written as a decimal, that's 0.1875. And written as a percentage, it's 18.75%. Okay, so that's the probability of certain events. The complement of an event, we talked about the complement yesterday when we talked about sets. We had complements of subsets, which was basically everything that wasn't in our subset. The complement of an event is the probability that an event not occurring. Okay, so the complement of a probability would be the opposite probability, basically. It's the probability that the event does not occur. Since the sum of the probability in a sample space is 1, the probability of an event not occurring is 1 minus the probability of the event. Okay, so what does that look like? Well, this first example, we can just use directly probability. It says a number from 1 to 20 is chosen at random. What is the probability that a number is not prime? So I've actually written down all the numbers, and here they are, 1 through 20. And the prime numbers are all red, while the not prime numbers are blue. Now I could count up all of the prime numbers and say, oh, I have this many not, excuse me, I could count up all the not prime numbers and say this is my probability, or how this wants us to solve it is count up all of our prime numbers. So we've got 2, 3, 5, 7, 11, 13, 17, and 19, which is 8. We have 8 prime numbers. And how I would find the complement of that is I'd do 1 minus the 8 out of 20 letters, excuse me, no numbers. 1 minus 8 over 20 is going to give me 12 over 20, which is going to simplify down to 3 over 5. And that would be the probability. Now we could have just counted up all of the non-prime ones, and if I would have done that, I would have ended up with 12 as well, but this is practicing using that complement, so that's why we did it the other way. Now, if our sample space is too big, maybe it's a lot easier to use the complement. So an example like this, if a state is chosen at random, what is the probability that it does not begin with the letter M? Well, there's a lot more states that don't begin with M than do begin with M. So it's easier to count up the amount of states that do start with an M. Now, there are 8 states that begin with the letter M. So we would solve this just by doing the exact same thing we did last time. We're going to take 1 and we're going to subtract the 8 states out of the 50 total states that begin with the letter M. And that's going to leave us only with the states that don't begin with the letter M. So we're going to have 42 out of 50 states that don't begin with the letter M. And that's going to simplify down to 21 over 25. And that's our probability. Okay, so that is simple probability. Now we are going to jump ahead in our notes to page 12, I believe, and we're going to talk about compound probability. So I'm going to jump here, page 12, or excuse me, page 13, looks like. We're going to start compound probability. So compound probability is the probability of 2 or more simple events occurring. Okay? Now, in the past examples, we've only been looking for the probability of one event at a time. Now it's multiple events happening. Okay, there's 2 different types of events. We've got independent events and dependent events. An independent event is when the outcome of one event does not affect the outcome of the other event. Okay, so we have the probability of A and the probability of B. So the probability of just 2 different events. How we're going to solve for this is we're going to take the probability of A and we're going to multiply it by the probability of B. So we take our 2 probabilities and we just multiply them together. Okay. So looking at some examples, it says a die is rolled 3 times. What is the probability of getting 1s on each roll? Well, these are independent because what I get on the first die roll has no effect on what I get on the second die roll. They're independent from each other. So I'm just going to look at one event at a time. What's the probability that I get that I roll a 1 on my first die roll? Well, there's only one 1 on a die out of the 6 total numbers. Then for the second event, I still have a 1 out of 6 chance to roll a 1. And same thing for the third event. So if I multiply all those together, I get 1 over 216. So the probability of rolling a 1 on each roll is 1 over 216. Okay, similarly, what is the probability of tossing a coin 3 times and getting tails each time? Well, when I toss a coin, I can either get heads or tails. So I've got 2 different outcomes. So my bottom's for sure going to be a 2. And the probability that I get a heads is 1 out of 2. So I flip a coin. The first time I have a 1 out of 2 chance. Second time I have a 1 out of 2 chance. And the third time I also have a 1 out of 2 chance. Multiply those together. I have a 1/8 probability or 1/8 chance of getting tails 3 times in a row. Okay, now we are going to skip this example here and move on to the dependent events. The outcome of one event does affect the outcome of another event in a dependent event. Okay, so independent, they did not affect each other. In a dependent event, they do affect each other. Okay, now how we're going to find these probabilities is pretty similar, just a little different. We're still going to take the probability of A, but now we're going to multiply the probability of A by the probability, and this is read, of B given that A already occurred. So this second piece right here is an adjusted probability because they affect each other. Okay, so we take our first probability and multiply by the probability of B occurring given that A already occurred. Okay, so what did that look like? Jack had 4 Snicker bars and 8 Mars bars. He randomly chooses a piece of candy, ate it, and then chose another one. What is the probability that both candy bars were Snickers? Okay, well, Jack has some candy bars. He wants to pull 2 Snickers out. That's what we're trying to look for. So the first time he reaches in and he pulls a Snicker bar out, he has a total of 4 Snicker bars in there. So we've got a probability of 4 over our total amount of candy bars. We've got 4 Snickers and 8 Mars bars. So we've got 12 total. So the first time he reaches in the bag, he has a 4 out of 12 chance of pulling out a Snickers bar. And we're going to multiply that by the adjusted probability of pulling another Snicker bar out. Why this is adjusted is because we've already pulled one out and eaten it. So we no longer have 4 Snicker bars in the bag. We now have 3 Snicker bars in the bag because we already took one. And we no longer have 12 Snicker bars in the bag because we've already taken that Snickers bar out. So we now have 11 total candy bars in the bag. So when we multiply these together, we get 12 over 132. And that simplifies down to 1 over 11. So we have a 1 out of 11 chance of reaching into Jack's bag and eating 2 Snicker bars in a row. Okay. In this next example, we have 3 green markers, 6 yellow markers, 4 red markers, and 12 blue markers in a pencil box. A marker is drawn, not replaced, and then another marker is drawn. Find each probability. Okay, so the first thing we want to know is how many total markers do we have? We have 3 green, 6 yellow, 4 red, and 12 blue markers. If we add all those together, we get 25 total markers. Okay? We're going to use this information to make our probabilities. So in A, it says find the probability of pulling a red and then pulling a blue. Well, we've got 4 red markers. So I've got 4 out of the 25 markers. And then because it says we do not replace the marker, we do not put it back in the bag, now we have a different amount of markers in our bag. We no longer have 25. And now we're going to multiply that by the probability of a blue marker. We've got 12 blue markers still. but we have 24 markers instead of 25. Okay? When we multiply those together, we get 48 over 600, which simplifies down to 2 over 25. Okay, now the probability of pulling a yellow marker and then a green marker, well, we've got 6 yellow markers out of our 25. And then we've got 3 green markers, but we no longer have 25, we have 24 in our box. This multiplied together gives us 18 over 600, which simplifies to 3 over 100. Okay, now what's the probability of pulling both blue markers out? Okay, so I reach in the bag and I'm gonna pull a blue marker out. I've got a 12 out of 25% chance. And then when I pull the second one out, I've already pulled one of my blue markers out, so I now have 11, and I have 24 markers instead of 25. So that multiplied together gives us 132 over 600, which simplifies down to 11 over 50. And now what's the probability of pulling both the yellow markers out? Well, we've got 6 yellow markers out of the 25. And then when we pull the second one out, we now have 5 out of 24 markers. That's going to give us 30 over 600, which is going to simplify to 1 over 20. Okay, so that is the end of notes today. We went over simple probability and compound probability. We do have a Delta Math online. And thanks for watching.